Okay. All right. Dear colleagues and friends, I would like to start by giving my most special thanks to Athens, Georgia and Yener Milanevski for their kind invitation to be part of the Arva Levant lecture series. It is a pleasure and honor. Very recently, I gave a lecture at Arva Anatolia regarding the in-depth understanding of the second millennium BC of the Amuq Valley of Hatay, by particularly concentrating on the results of the multi-proxy archaeological research program conducted around the capital city of the Kingdom of Mukish, Atchana, and Toprakhisar Höyük within the larger frame of the Amuq Valley Regional Project. Today, we will concentrate on the preliminary results of the large-scale and multi-proxy sediment coring program in the Amuq Valley. Thus, in the first part of this lecture, I will only provide a summary of the results of the ongoing archaeological missions where major episodes of cultural, political, and economic processes are defined. The environmental data, which is the main focus of this lecture, will be presented by my colleague Ulaş Avşar, the director of the geoarchaeological research program in the Amuq. In the last section of this presentation, I will present our interpretative understanding of the relationship between geological and archaeological data. And afterwards, we will be delighted to hear your opinions in the discussion. The Amuq Valley of Hatay, located in the southernmost fringes of Turkey, has a crucial value in understanding particular periods of transformations. As we state, it has not only been a region of rich agricultural potential through time, but also a buffer and an impact zone where traces of cultural, economic, and political interactions between Anatolian, Near Eastern, as well as Levantine, Egyptian, and Aegean counterparts can be traced from stages of chiefdoms to city-states and then to kingdoms and empires. Presenting at Arva Anatolia and now at Arva Levant mark the significance of the Amuq Valley to its connected and neighboring regions. This certainly owes to Braidwood's pioneering survey and excavation program in 1930s. The established regional chronology still stands as an anchorage point for researchers interested in the larger understanding and synchronization of cultures over longer durations. Thus, the region has the potential to provide answers to a long list of research questions that dominate the literature, from modes of cultural interaction to state formation, collapse, re-urbanization, imperialism, or long-distance mobility patterns. In addition to the presence of a rich archaeological data set, Amuq Valley offers the possibility to test the relationship between climate change and societal reactions through time. This is due to one of the most remarkable aspects of the valley that defines the methodological starting point of this research, the presence of the now drained Amuq Lake. In theory and in practice, the presence of a lake allows us to reconstruct the micro-environmental history of a region and to correlate it with archaeological data obtained from high-resolution stratigraphical excavations conducted in the region. In other words, for an archaeological understanding of the impact of global climatic events such as 8.2, 4.2, 3.2 kbp, or for micro-regional, less discussed events such as 5.2 K, or impacts of catastrophes such as the Santorini eruption, we don't need to go far away to seek for paleo-environmental data. This theoretical and methodological approach to Amuq Valley is not new and was first implemented during the second round of archaeological surveys conducted by Kutlu Aslan Yener. By then, the main goal of the survey was to understand the shifting settlement patterns in relation to the turmoil political history of the Near East and Anatolia via interconnected research strategies targeting the exploration of environmental and anthropogenic factors over the changing landscape. Tony Wilkinson's geoarchaeological research program set the foundations of the sediment coring strategies developed especially in and around the Amuq Lake and in the vicinities of Tell Atchana and Tell Tayinat. The first round of geoarchaeological research program resulted with the understanding of the gradual expansion of the Amuq Lake from Chalcolithic to Iron Age, providing the first data set to define the relationship between changing landscape and the responses given by the inhabitants of Amuq Valley under diverse political and cultural entities. The results brought up the potential of geoarchaeological research in an alluvial floodplain and took the landscape further beyond being treated as a passive background. Then it became a primary interest for teams of Tell Atchana and Tell Tayinat. The efforts and motivations of both teams relied on the fact that settlement shift occurred between these two tells corresponding to time periods of 4.2K and 3.2K BP events, thus making it necessary to cross-correlate alluvial sedimentation with archaeological sequences. As part of the new round of Amuq Valley Regional Project, we expanded this approach by first designing new mechanical systems to acquire truly undisturbed sediments to collect environmental data. Sample variation is increased by selecting different coring locations that included both the lake and the nearby stratigraphically excavated archaeological sites. The correlation strategies included absolute and relative dating methods, as well as the relationship between environment and plant consumption patterns. The sites include the late 7th to 5th millennia BC settlement of Tell Kurdu, 3rd to 1st millennium BC capitals of Tell Tayinat and Tell Atchana, and the relatively new excavation project of Toprakhisar Höyük on the southwestern outskirts of the Amuq Valley. Although the Amuq Valley has a long historical research, unfortunately, there are still some of the major periods that are not properly understood in the valley. The renewed excavations directed by Rana Özbal from Koç University will now provide the possibility to understand the early phases, especially the early Neolithic phases in the region, and the establishment of the site following the 8.2K BP event. And hopefully with Rana Özbal's renewed excavations, we will get more information about the prehistoric sequence of the Amuq Valley, especially on the northern part. And when we go to the actually southern side of the valley, here comes the relationship between Tell Tayinat and Tell Atchana. We know that both of these sites occupied in a time period stretching from 3rd millennium to end of 2nd millennium BC and then to 1st millennium BC, but their relationship was always entangled. So we know that there is the early Bronze Age occupation at Tell Tayinat, then we have the 2nd millennium BC occupation at Atchana, and then there is a shift back to Tell Tayinat. But the recent excavations shows that this scenario is a little bit more complicated than expected, since Atchana is also now producing Iron Age material. But of course, the beginning of this story is more interesting because we learn about the name of the city, Alalahum, from Ebla archives from 3rd millennium BC. But when we come to the Amuq, the textual evidence is actually coming from the level 7 Middle Bronze Age, level 7 palace complex. So this means that at least the name in the early Bronze Age was very much likely related with Tell Tayinat. Of course, this is followed by an uninterrupted 2nd millennium BC sequence at Tell Atchana, where we have the evidence for both the Amorite kingdom of Yamhat with the Yarimlim dynasty, followed by the Mitannian hegemony in the region, and this is represented by Idrimis dynasty, and this was successfully replaced by Hittite administration. But because of the problem in terms of our data gaps, we really don't know what's going on in the beginning of the second millennium BC, especially at Atchana. But there is also a second cycle of shift, and at the Iron Age, the occupation, as I said, continued at Tayinat, but Iron Age remains were also encountered at Atchana, especially around the temple area. So recent discoveries now further adds to the fragmented nature of the evidence regarding the end of late Bronze Age, when the site witnessed to a dramatic period of collapse beginning at the, let's say, early 13th century BC. So this relationship between these two sites has been framed by Aslıhan Yener under the larger concept of a megacity, expanding into two tells where its different sectors were settled in different times, being dependent on the shifting riverbeds of the Orontes River. So the extensive boring operations conducted at Tayinat, but then also at Tell Atchana, show that likely in the second millennium BC, Tell Atchana was surrounded by the Orontes River. That's throughout the whole second millennium BC. But the relationship between the Orontes River and the city kingdom of Alala in the Middle Bronze Age was more presented in a two-dimensional form from publication plans, as there was not really much visuals left from this time period. Now, following a century-long process of decay, the gate system was physically inaccessible and lost. So our understanding of the relationship between monuments and their surrounding landscape was also lost. As we recently accomplished the preservation project of the Middle Bronze Age city gate, our perception is now also altered. So, I mean, this is not really a fantastic artistic work, but here we can see that the massive Middle Bronze Age gate complex seen in this slide was also likely accessed by boats and perhaps be regarded as a water gate, providing not only protection, but at the same time, riverine transportation, especially, which is important when we look at to Middle Bronze Age too, when public monuments required heavy raw supplies. So I believe riverine transportation was necessary in this time period. And of course, this is a tradition that's still alive and still something that you can see in the Amuq Valley when you go specifically to northern part, to Kırıkhan region, where there's still marshes and where there are people using boats to navigate and to do fishing activities. But when we look at the beginnings of the second millennium BC, unfortunately, we don't really get much information about this from the standpoint of Tell Atchana, as the Middle Bronze Age soundings for the earlier part of the second millennium BC, they are very limited in terms of the data that they present. And today, the archaeological research so far conducted at Atchana provides the earlier Middle Bronze Age sequence, but unfortunately, this is still not enough to understand the third to second millennium BC transition. And same thing may also count for Tell Tayinat, because we have the end of third millennium BC at Tell Tayinat with their EB4B exposures, but the gap between Tayinat and Atchana from an archaeological standpoint of view is still there because we don't have that data from both of this site. So, but when we look at on this recent project that was concentrated on the human remains from Atchana, what we see, which is a very interesting point, is that the Middle Bronze Age human remains from Alala, from Tell Atchana, shows a significant change in their genetic makeup when you compare with the Ebla early Bronze Age examples. So it seems like at the end of third and the beginning of the second millennium BC, there seems to be political and a cultural change that we may trace also through the DNA as well. So where we get this transitional time period from third to second millennium BC, this is actually where I would like to take you to the site of Toprakhisar Höyük, which is located rather in a highland area in the Altınözü region of Hatay. So this is a relatively very small scale site, and because there was a dam constructed in 1980s, this was a necessity to run a research rescue excavation in the region because most of the site was already damaged by the dam itself. And we were quite lucky because from the very first day of excavations, it was maybe let me say it's our luck because we hit into a Middle Bronze one administrative building complex, and this was exactly the time period that we were missing from in our sequence from the Amuq Valley. And the almost 7 years of excavations now allowed us to understand what's going on from EB4B to MB1, and both from an architectural perspective and material culture perspective, we do see a significant change in a peripheral site located in the fringes of the Amuq Valley. So this allowed us to create a continuous sequence from the same site and also to define the changing patterns in the material culture. And thanks to high resolution C14 dates acquired from Tayinat, now we have the possibility to create a tentative chronology that connects these two sites and also puts Atchana all the way to the end. So from basically end of 3rd millennium BC to the entire 2nd millennium BC and then to 1st millennium BC, we have a chronological sequence established through this material, through this data set. So in this part of this presentation, I wanted to present you what we have in our hands in terms of the archaeological material and these critical time points that are important in terms of understanding these major climatic events. And now with this archaeological data in hand, Ulaş will talk about the sediment data, and let's see how we can correlate this. So I'm now letting Ulaş talk from this moment onwards.
Okay, hello everyone. I guess you can see my screen. Could you confirm?
Yes, all good. Thank you.
Okay, thank you. Thanks, Murat. Thanks a lot. You gave lots of valuable archaeological information, and I think it's time to talk about a little bit geology, what we did, what have we been doing in Amuq Valley. So, in fact, we started a project in Amuq Valley, already mentioned. It's titled Geological and Archaeological Traces of Climatic Change in Amuq Valley during the Holocene. So within the scope of this project, we collected many core samples from Amuq Valley. We also study on archaeobotany, paleobotany, palynological studies, and we have lots of multi-proxy analysis going on. It started in March 2020, and it is going to end in approximately 3 months. So throughout my talk, I will first talk about the motivation, why we're doing this investigation, this study. And then I will talk a little bit on previous works, what kind of paleoclimatic records that have been obtained from the Eastern Mediterranean. And there are some problematic points about these records. I will discuss a little bit about them. And then I'm going to talk about the sampling and coring methods we applied, because these methods are quite different than the methods applied previously in the previous studies. And then finally, I will talk about the current progress of the project and what kind of preliminary results we obtained in terms of we obtained from sediments, basically. So the main research question of our project is on did climatic change obtained from geological archives really affected or affect human life and activities? This is the main question, and we try to find if we can find the traces of human activities in the sedimentary sequences around the mounts in Amuq Valley. Amuq Valley is a specific or special place in terms of geology because it is just in the floodplain of a meandering river. First of all, I need to briefly explain what floodplain is, and I need to briefly explain how the sedimentation takes place in this kind of geological settings. So here you can see we have a meandering river, which is Orontes in our case. And in normal times, the water flows in the channel, but during the flooding times, you have lots of water and you can bring lots of sediments in the floodplain. And when the flood is gone, everything becomes normal, but you put a little bit sediments in the floodplain. During each flooding period, we have a little bit of sediments in the floodplain, and in this way we have almost continuous sedimentation in the floodplain. So if we have sediments, it means that there's something recording environmental change, environmental properties. So that is why Amuq Valley is quite important. As you see here we have Atchana, and here we have Tayinat. This is our Orontes channel, which is a very beautiful, well-developed meandering river, and all of the region, as all of the sediments around these mounds are floodplain deposits of Orontes River, in fact. So as time passes, we have almost continuous deposition of sediments. In addition to floodplain deposits, we are lucky that we have a lake as well in Amuq Valley. This is Amuq Lake. So lakes are much better sedimentary or depositional environments than floodplains because they're mostly are covered by water and they're protected. The sediments or sedimentary record is protected by that water. So we can have much better and well-preserved sedimentary sequences in lakes. So what we are doing, here we have an hypothetical drawing of the region. Here we have mounds, here we have Orontes River and floodplain deposits, and we have lake. So we collected cores from the lakes, and we collected cores from around the mounds, around Kurdu, around Atchana, and around Tayinat. And also we collected cores from Toprakhisar. So in these cores, in these sedimentary cores, we are investigating the paleoclimatic changes in terms of proxy recourse. Now let's check what happened, what kind of information we have in the Eastern Mediterranean, roughly, in terms of proxy recourse of paleoclimate. These dots are studied sites in the Eastern Mediterranean, and all of these sites, the results of them are plotted in this figure. So the left-hand side, the anomalies towards left, tells you dry periods from these records. As you may recognize, for example, here we have anomalies showing dry periods, but if you put it 3.2 TA, some of the records are successful, but some of the records, they have shifts from the chronological shifts from the known dry periods. On the other hand, you can also recognize at the first glance that these records are not correlating well. So in a regional scale, let's say having a diameter of 200 kilometers, the common sense tells us that the climatic change should be recorded and climatic records, paleoclimatic records should correlate each other because the climate is changing in the same way. If you have dry period, the proxy record taken from a lake should correlate with the proxy record from another lake approximately 100 kilometers away. The problem in the region is the records are not correlating well. So there are some reasons of this. First of all, proxy methods already have complexities in them. So they are not the direct measurements or direct estimations of temperature or precipitation values. Another problem most of the studies uses few radiocarbon dates. So we have chronological problems in the records. And the other one that we basically try to eliminate in this project, the core quality. So in most of the studies, there is no mention about the core quality. During coring, we need to be careful because we need to take the first step properly in order to achieve correct conclusions. If we cannot take the core properly, we may lose sediments in the sequence. So we may misinterpret some anomalies in the sedimentary records. So what we do, before I met Murat, I was working on lakes and in marine environments with my coring platform like this. And we were collecting cores from the bottom of the sea or lake. We were stabilizing our platform like this with anchoring, and we lowered the system to the bottom, and by hammering, we can easily obtain undisturbed sedimentary cores. If you look at closely, here as you hammer it, we have PVC pipe penetrating through the sediments, into the sediments, but we have piston here, which creates equalized, balanced vacuum during each hammering so that you can eliminate the internal friction created by penetration. If you do not use coring, if you do not use piston, during each hammering, because of the internal friction in the pipe, you're going to push your sediments down and down, and you're going to squeeze them. On the other hand, at the tip of your corer, you may lose some sediments. So in the end, you're going to have much shorter sequence in your core, and you're going to lose sediments. And you will never know from which depths you lost your sediments. Mostly in coring applications in geoarchaeological studies in the world, people use rotary double tube coring. So this is also another problem about coring in this kind of environments, because during drilling, you have rotation, plus you have circulation of water from this tube inside, and then it moves outwards in the well. During this water circulation, you can dissolve soft clays and sands easily. So in fact, you're losing material, you're losing sediments. So during each 1.5 meters drive, you're going to add them on top of each other, and in between them, you're going to have lost information. So it may easily lead you misinterpreting the paleo-environmental changes. What we did basically after meeting Murat and in order to collect cores from Amuq Valley, first of all, we increased the weight, hammering weight. We were using around 10 to 12 kilograms. We started to use 65 kilograms of hammering weight. We started to use aluminum pipes too, in order to have a stronger system. We used the piston, of course, and at the bottom, we have a core catcher. We started to use a chrome catcher at the bottom of our system. In this way, we were able to collect cores, which are cores from floodplain deposits, which are much, much stronger and stiffer than marine or lacustrine lake sediments. Around Toprakhisar, we used our platform because we already had a dam. We have water, so we directly use our system like this. But in the Amuq Valley, we use a drilling rig, and we attached our system to the drilling rig. And sometimes even the power of the drilling rig was not enough to penetrate our pipes into the sediments. So we were helping it with this kind of efforts. Let me show you some examples from the cores from Toprakhisar. We collected this many. Here we have the Toprakhisar mound, and here we collected the cores all around the mound. These are the optical images of the cores. Now I will show you how undisturbed our cores are. If you have a closer look at this level, for example, you can clearly see the sediments, the layers are almost horizontal and they are flat. So normally the sediments are deposited horizontally. you should not see any deformation in them in order to claim that your core is undisturbed. So you can see here, this is almost an undisturbed, perfectly undisturbed core. You can even see very tiny layers, laminae that are probably related to floods in the region. A little bit above to this region, as you see here, almost undisturbed layer, and above it you have a chaotic sediments. This is another story about the earthquakes of Dead Sea fault. In fact, during the shaking of the lake or sediments, you can easily create this kind of deformations, and this deformation is most probably related to the earthquakes of the Dead Sea fault. It is not because of coring. This layer here and this layer here confirms the success of undisturbed coring. Close to the bottom of your core, this is really important. Here we have fine-grained sediments, clay and silt, and fine sand. But at the bottom we have gravels, okay? We have even pebbles in the core, in the same core. We did not change the method. So with this method, we were able to collect continuous cores from finest grained sediments to very coarse grained pebbles. So it was quite successful. So in the end, we can say we could collect many cores from around Toprakhisar. So as you see here in the same core, fine grained sediments and very coarse grained sediments at the same time without changing any methods. Anyway, so now we can talk about what else we did in Amuq Valley. We collected 20 cores. You can see the locations here. For example, around Atchana and Tayinat, here you can see a closer view. Around Atchana, we collected 5 cores like this at these locations. And around Tayinat, we collected 2 cores. Just next to Kurdu, we collected 2 cores, as you see here. And in the Amuq Valley, we collected many cores, 11 cores, I guess, we collected along a profile. This is quite important. We did not prefer to collect only 1 core. If it was so, we would have to totally rely on proxy reports. But here we are trying, in addition to proxy reports, we want to see the size of the lake. We want to correlate these cores, and we want to reconstruct the size and shoreline of the lake, how it changed, so that we can give much better information about dry periods or wetter periods. So in the end, we collected undisturbed 206 meters cores at 20 locations. And in addition to proxy reports, as I already told you, we're going to check the real geometrical change of the lake. So we're going to have lots of radiocarbon dates as well. So if you check, for example, Amuq Valley, Amuq Lake cores, the images are extremely small. So here, let me switch to real pictures in real images in Photoshop. We need to check, we can zoom in here, for example, to the bottom of the longest core. It is about 21 meters long. And here, for example, you have a flood event here. And if you look at very closely, so even at around 19 meters deep, we have almost undisturbed sediments. They're almost flat and horizontal. So this made us very happy that we could collect undisturbed and complete reports, sedimentary reports from Amuq Valley. So what we are doing in this project, basically, let me tell you a little bit about the methods, analysis we are using. First of all, of course, we are doing radiocarbon dating, but until now we are having some difficulties to find datable material, organic material in the cores, and we're extracting microcharcoals, and it takes really a long time. So currently we do not have any radiocarbon results, but we have collected lots of data on the cores, such as magnetic susceptibility measurements were completed, geochemical measurements, both XRF and ICP-MS and OES measurements have been completed, all in the cores. And also we do ICP-MS measurements on the mud bricks as well. And what else? We have mineralogical measurements. We always try to confirm our results, geochemical or mineralogical results, with different methods in order to be sure if we see any anomaly in the records. In addition, we are also working on palynological records. In these cores, pollens are extracted. And we also use paleobotany methods, and paleobotanical contents of the cores have been investigated. And we also have archaeobotanical studies from the mounds. Of course, we produce lots of data. We produce incredible amounts of data, and we have a little bit crowded team. But here, I'm not going to talk about the things other than my expertise. So I will explain here about the sedimentary geochemical records we obtained from the cores. So let me show you some examples from magnetic susceptibility measurements. For example, this is from the cores around Atchana, 5 cores we collected from Atchana, and these are the magnetic susceptibility measurements all along them, and we can easily correlate them. Okay, we can almost peak by peak correlate all of these cores. So this also confirms the success of undisturbed and complete coring sediment cores. These were from Atchana, and these are from the cores around Kurdu, KR1 and KR2. We can easily correlate between magnetic susceptibility curves. And also we have 2 cores from Tayinat Mound. They also can be easily correlated by magnetic susceptibility measurements. And this figure illustrates the magnetic susceptibility measurements of the cores all along the profile, all along the line, passing through the Amuq Lake. So AL5 is the longest core. It is almost 19 meters long. And again, we can easily follow the correlation among the cores. So this is important. So in this case, we can reconstruct the geometrical change, the size. We can reconstruct the size of the lake in the end. So these are all just a very small proportion of the data. It is just magnetic susceptibility. And I guess we do not have that much time to present all of the data, but let me give you more examples from XRF measurements. Okay, so this is the Amuq Lake core, which is located here. It is the deepest, longest core at the deepest part of the lake, and it is 19 meters long. And you can see the measurements of ITRAX, micro XRF, and you see some elements: aluminum, silicium, potassium, titanium, iron, manganese, calcium, and strontium here. These are the main elements, but we have 10 more elements measured by ITRAX XRF as well. So these measurements are at every 2 millimeters. So we have really high resolution XRF measurements along the cores. So this is from Amuq Lake, and here we have the core, ITRAX micro XRF results of Kurdu core. And again, you see lots of elements. Most of them correlates well with each other based on some geological principles. And what else? Here we have the cores 81, 82, and 83 from Atchana Mound, just next to Atchana. And again, we also have high resolution micro XRF results. And this is finally from Tayinat. This is Tayinat core. So currently, this data may seem meaningless to you, because I do not want to create a mess in your minds, because we have lots of data, but I will try to summarize what we are seeing in the cores currently. So what we expect, what is the geochemical significance or geochemical indicators of, for example, dry periods? So as I already mentioned, we are in a floodplain. Okay, so during a flood, what happens? Imagine we are collecting a core from here. What happens during a flood? During a flood, we have sediments arriving to our quarry location. So titanium, for example, represents the aluminosilicate minerals. Okay, during this flood, we may have lots of aluminosilicate minerals coming to our quarry location. After the flood is gone, what happens? The water slowly infiltrates into the ground and also it evaporates. And during this mechanism, we also deposit lots of carbonates. And carbonates can be represented by calcium as well. So during the next flood, again, we are going to have titanium. And after the flood, we are going to have evaporation and deposition of carbonates, which is represented by calcium. So if we divide them to each other, calcium or titanium, and if we plot them, so any anomalies in this kind of curve will tell us that these are dry periods, because we have less, during dry periods, we have less floods, so we have less titanium content. Less titanium content means higher values in this ratio. So any kind of anomalies like this can be interpreted as dry periods in this region. So let's see what kind of data we have, results we have. Here, AL5 is the Amuq Lake core that is located here. And this is its plot, calcium or titanium plot, all along 19 meters long core. And as you see, as you can easily recognize, we have some anomalies along this core, anomalies in calcium or titanium ratio, which means these are dry periods. These are most probably dry periods. On the other hand, what we have here in reddish colors, we have KR1 core, which is from Kurdu Mount, and you can easily correlate, stratigraphically correlate their calcium or titanium record. As you see, not as prominent as in the lake, we also have anomalies in Kurdu record as well. Okay, it is expected because lacustrine records are much better, much more protected compared to floodplain deposits. So the anomalies are much well preserved in the lake record. So let's check another correlation in the calcium or titanium ratio. This is AT1 core, here Atchana core, correlation of it with the Amuq Lake core. Again, we see very similar anomalies, and the general trends of the cores, calcium or titanium measurements, fit quite well. So regionally, in this valley, in Amuq Valley, regionally, we can easily correlate, geochemically correlate these cores quite well. So this is a very good news for us. So let's look at more in detail in terms of chronology, what we can do without radiocarbon dating. So this is the results of Amuq Lake record, Amuq Lake core, and this is calcium or titanium record from iTrax scanner, 2 millimeters resolution. And this is also calcium or titanium report from ICP-OES measurements, and its resolution is every 12 centimeters. So they almost perfectly match. What we recognize here, again, we have anomalies showing drier periods. So let's make a try to construct an H-step model for this report. First of all, you can see a general trend, fluctuation, sinusoidal fluctuation in these reports, as I show here with blue regions, blue lines. And just out of these lines, you can much easier recognize the anomalies. So what we can say, close to the bottom of the core, as you see, we have a shift, almost a shift towards drier conditions. And if we assign that this is Holocene Pleistocene transition at this depth, and if we put our dot in the H-step model, so you can roughly try to estimate the age of the events. So here, for example, this anomaly, this very, let's say, tiny or non-distinct anomaly, maybe 8.2 Ka. It really fits well with the HSEP model. And here we have 5.2 Ka, this dry period. And here we have 4.2 Ka, perfectly matched with our tentative HSEP model. And also we have 3.2 perfectly matching to our tentative HSEP model. So in the end, along this Amuq Valley core, which is most well-preserved sedimentary sequence in the project, we can calculate the sedimentation rate of 0.19 centimeter per year, which is highly consistent with the previous dated, radiocarbon dated records in Amuq Valley, in Amuq Lake. So in the end, what we can say, for example, 3.2 dry period, dry event, 3.2 Ka, it is 30 centimeters thick in this core, and it corresponds, yields 160 years long period. On the other hand, 4.2 must be approximately around 290 years long, based on its thickness. And 5.2 seems to be around 130 years long. And finally, the 8.2 event looks like it was 240 years long in this valley. So this is quite tentative HSEP model. We are extracting microcharcoals from these cores, and we're going to obtain radiocarbon dates in a few months. But tentatively, it looks like we have a very good chronological model here. So in the end, in addition to dry periods, 3.2, 4.2, 5.2, 8.2, we also have some wet periods in the record. Just before 5.2 event, for example, we have a significant implication of a wetter period. Just before 3.2, we have two quite significant wetter periods. We have this kind of implications, but we're going to make more detailed measurements, especially in terms of ICP measurements, ICP OES measurements. We are going to make these anomalies much more in detail. So at this stage, I put everything that I can say, but I'm sure I left some parts out. If you have questions, I can easily, I would be happy to answer them. But just before I'm leaving the stage, I need to leave the stage to Murat with this figure so that he can give you a little bit more information about the archaeological meaning of this environmental record. Thank you.
Okay, hello again. I just want to give a quick summary of what we are thinking right now. Of course, we don't want to correlate every archaeological event with environmental change. Maybe this may not be the right approach, but interestingly, as Ulaş repetitively mentioned, this chronological framework and the visible data that we have on the screen is not going to change. So that means at least starting from end of 4th millennium BC onwards, we seem to have dry periods that are correlating very well with what we conventionally define in our archaeological understanding as change. And also interestingly, I prefer not to talk in detail about the prehistoric sequence because as I stated in the Amuq, there is a big gap for understanding the earlier time periods. But when we go specifically to the end, from end of 4th millennium BC all the way to 1st millennium BC, what is interesting also to note that all these wet episodes that Ulaş marks are also in our archaeological understanding. They represent significant time periods, such as when we look at 3.5 and 3.8, these are the time periods when we see the beginning of Middle Bronze II, so the re-urbanization event, or the time period, especially when we look at from a Atchana perspective, the construction of the level 4 palace and the let's say, the second re-urbanization phase in Late Bronze 1. So in every 1,000 year also, there seems to be an anomaly going on in the Amuq, and this, in our archaeological understanding, correlates well. So at this stage, I think it will be best to answer now your questions, because this is our preliminary understanding of what's going on in the Amuq Valley from both archaeological and geological perspectives. Thank you. Teşekkür ediyoruz. Öncelikle bizi Arba Levant online oturumuna davet ettiğinizi teşekkür ediyoruz. Biz bu proje kapsamında bugün özellikle Amuq Ovası özelinde yürüttüğümüz arkeoloji ve iklim arasındaki ilişkiyi araştıran projenin ön sonuçlarını sunmaya çalıştık. Bu çalışma kapsamında ve bu sunumun akışında ağırlıklı olarak arkeolojik veriden ziyade çevresel veriyi ve yani burada yürüttüğümüz karot çalışmaları kapsamında elde ettiğimiz veriyi sunmaya önem gösterdik. Bölgede yürüttüğümüz ve arkeolojik verileri elde ettiğimiz sunumlar birçok farklı online oturumda verildiği için biz böyle bir akışı tercih ettik. Ama özetlemek gerekirse Amuq Ovası özellikle hem 1930'lardan günümüze kadar devam eden zengin bir arkeolojik araştırma geçmişine ve bu arkeolojik araştırmalardan elde edilen yüksek çözünürlüklü veri setlerine sahip olduğu için ve bunun yanı sıra aynı zamanda günümüzde kurutulmuş olmasına rağmen geçmişte var olduğunu bildiğimiz Amuq Gölü'nün varlığı nedeniyle arkeolojik ve jeolojik verinin bir arada eşleştirilebileceği önemli bir coğrafya haline geldiği kurgusu üzerinden bu projeyi gerçekleştirdik ve bu bağlamda özellikle Amuq Ovası'nda stratigrafik ve yüksek çözünürlüklü arkeolojik sonuçların elde edildiği Tell Kurdu, Tell Tayinat, Tell Atchana, Toprakhisar gibi uzun soluklu arkeolojik kazıların yürütüldüğü noktaların civarından elde edilen sediman karotlarıyla Amuq Gölü üzerinden aldığımız sediman karotlarını eşleştirerek arkeoloji ve jeolojik literatürde 4-2, 3-2 gibi önemli iklim anomalilerinin arkeolojiyle ya da arkeolojik veriyle olan ilişkisini anlamaya çalıştık ve bu bağlamda bizim özellikle 4-2 ve 3-2 olarak tanımladığımız erken Tunç Çağı sonu, geç Tunç Çağı sonu gibi dönemlerde gördüğümüz önemli arkeolojik literatürde yer alan sistem çöküşleri ya da kırılma noktalarının izlerini jeolojik olarak da takip edebileceğimizi gördüğümüz sonuçlar elde ettik. Ama tabii ki bu çalışmanın tek çıktısı ya da temel nihai amacı iklimsel değişikliklerle bütün arkeolojide gördüğümüz değişimleri eşleştirmek değil, ama özellikle iklimin de önemli bir etkileyici faktör olduğunu söyleyebiliriz. Bu konuşmanın Türkçe kayıtları, benzer Türkçe kayıtları farklı online oturumlarda verildiği için ilgilenenler birazcık YouTube falan araştırdığında bu karşımıza çıkabiliyor diyorum ve hızlıca Ulaş'a devrediyorum. Ulaş da özellikle bu projenin metodolojisini özetlediği zaman sanıyorum ki Türkçe özetimizi de vermiş oluyoruz. Teşekkür ederim.
Ulaş, we can't hear you.
Can you hear me now?
Yes, yes, thank you.
Okay. Murat Hoca'nın verdiği bu değerli bilgilerin ardından ben de projeyle ilgili daha detaylı sedimenter kayıtlarda, sedimenter istiflerde, Amuq Ovası'ndaki sedimenter istiflerde Holofen boyunca yaşanmış olan iklimsel değişikliklerin sedimanlarda nasıl kaydedilmiş olabileceğine yönelik olan projemizle ilgili hızlıca bilgi verebilirim. Öncelikle Amuq Ovası bir baskın ovası. su baskını ovası ve su baskını ovalarında da zaman geçtikçe görece düzenli sedimentasyon olabiliyor. Şu bölgeden karot aldığımızı düşündüğümüzde her sel su baskını sırasında bir miktar sediman geliyor ve gittikten sonra, su baskını gittikten sonra biz karbonat çökelimlerinde de eşlik edecek şekilde görebiliyoruz bu su baskın alanlarında. Tayinat ve Atchana höyükleri ve Kurdu höyüğü etrafında sedimanlardan örselenmemiş karotlar aldık. Ve diğer taraftan da eski Amuq Gölü, şu anda kuru olmasına rağmen eski Amuq Gölü içerisinde de bir hat boyunca birçok örselenmemiş sediman karot örneği aldık. Ve paleoiklimsel kayıtlar elde etmeye çalıştık. Bunlar bölgedeki diğer elde edilmiş, Doğu Akdeniz'de elde edilmiş diğer paleoiklimsel kayıtlar. Buralarda bazı tutarsızlıklar olduğunu biz fark ettik. Özellikle kronolojiyle ilgili. Kronolojiyle ilgili olan bu tutarsızlıkların da bir miktar önüne geçmek için bol miktarda karot alıp bol miktarda da radyokarbon tarihlendirmesi yapmaya çalışacağız. Kullandığımız sistem denizlerde ve göllerde piston karot sistemi olarak bilinen bir sistem. Denizin, gölün tabanına karot yağı bu şekilde aşağıya indiriliyor ve çakma işlemi ile PVC boru sedimanların içerisine penetre edilmiş oluyor ve böylelikle sedimanı örselenmemiş bir şekilde alabiliyoruz. Bunlar metodolojik bazı detaylar. Bunları biraz hızlıca geçmek istiyorum. Temelde aldığımız karotların ne kadar örselenmemiş olduğunu göstermek için bazı karot fotoğraflarını burada gösterebilirim. Oldukça yatay ve düz bir şekilde laminasyonlar görüyoruz karotlarda. Bunlar karotların sediman karot alma operasyonunun oldukça başarılı geçtiğini bize gösteriyor. Aynı karotun içerisinde hem silt, kil malzemesinden karot alabiliyoruz. Hem aynı zamanda da çakıllı malzemeden, oldukça iri çakıllı malzemeden de karot alabildiğimizi gördük. Biraz daha ilerlersek, Amuq Gölü'nden bir sürü karot aldığımızdan bahsettim. Birçok yüksek çözünürlüklü ölçüm yapıldı bu karotlar boyunca. En önemli ölçümlerden biri 2 milimetrede bir yapılan ölçümler ITRAX mikro XRF tarayıcısı dediğimiz META Deniz Araştırmaları Dairesi'nde bulunan bir cihaz bu. Bu cihazla yaptığımız ölçümlerle 2 milimetrede birçok elementin dağılımlarını bu şekilde karotlar boyunca elde edebildik. Birçok karotta bunları yaptık tabii ki ama ilerleyecek olursak bir miktarda Amuq Gölü karotunda ne tip data elde ettiğimizi hızlıca göstermek istiyorum. Dediğim gibi şeyler sırasında, su baskınları sırasında aluminosilikate minerallerinin baskın olduğu birçok sediman karot lokasyonumuza gelebilir. Titanyum genellikle aluminosilikat minerallerini temsil eden bir element olarak kabul edilir. Su baskını gittikten sonra, sel gittikten sonra da yavaşça karbonat çökelimleri olabiliyor bu tip bölgelerde. Karbonatlar da çok basit olarak kalsiyum ile tespit edilebilir, temsil edilebilir. Kalsiyumu titanyuma böldüğümüzde öyle bir orana karot boyunca baktığımızda doğal olarak kalsiyum bölü titanyum grafitlerinde anomali veren, yüksek değerler veren yerlerde daha az sel olmuş, daha fazla karbonat çökelimi olmuş. Yani bunlar kurak dönemler anlamı çıkarılabiliyor. Oldukça basit bir yaklaşımla. Şimdi Amuq Gölü karotundan ne tip bilgiler elde ettiğimizi hızlıca göstereyim. Burada kalsiyum bölü titanyum grafiğini görüyorsunuz. ITRAX mikro XRF'den 2 mm çözünürlükle elde edilmiş grafik bu. Bu da ICP-MS OES'lerden 12 santimetrede bir elde edilmiş yine jeokimyasal datanın kalsiyum bölü titanyum oranları. Birbirlerini tamamen neredeyse tutuyorlar. Sadece çözünürlükleri farklı. İlk bakışta ana trendi görüyorsunuz. Burada mavi renkle gösterilen yerlerde. Ve anomaliler görüyoruz kalsiyum bölü titanyum oranlarında. Ciddi anomaliler bunlar. Biraz karotu tarihlendirmeye çalıştığımızda elimizde şu anda radyokarbon yok ama şuranın Holosen-Pleistosen geçişi olduğunu kabul edebiliriz. Tabana bunu koyduğumuzda ve düz bir çizgi çizdiğimizde 2020 yılına doğru 0.19 santimetre bölü yıl sedimentasyon oranı elde ediyoruz ki bu daha önce burada çalışılmış olan şu lokasyonda ve şu lokasyonda çalışılmış olan karotlarda radyokarbonlar sonucunda elde edilmiş sedimentasyon oranıyla tamamen tutarlı bir sedimentasyon oranı. Ve gördüğümüz kuraklıkları da literatürde biraz iyi bilinen 8.2K, 5.2K, 4.2K ve 3.2K olarak buraya plot ettiğimizde bunların hepsinin tutarlı bir şekilde derinliklerinin bu olaylara kurak döneminde denk geldiğini net bir şekilde görmüş oluyoruz. Ve bu şekilde yaptığımız çalışmanın ana temel sonucu şu anda bu şekilde aslında tamamen gösteriliyor. Ama ilerleyen dönemlerde bunu daha detaylı bir hale getirmeyi planlıyoruz. Teşekkür ederim ilginiz ve sabrınız için. Thank you.
Thank you. Teşekkür ederim, both of you. And
You're welcome.
have a lovely continuation of the project. And we look forward to the results. Thank you again for agreeing to this, and all the best to you and your research.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye.
Good night.